let's classify elements in a little more detail. By the end of the video, you should be able to differentiate between different classifications of elements and classify them as metals, nonmetals, and metalloids with their properties. So elements consist of one type of particle and can't be broken down. Remember we talked about monatomic elements where they stay as ones, all separated, and diatomic where they're like kind of twins, like H2. The metals are on the left side of the table, and most of the elements on the periodic table are metallic. The right side of the table has those the nonmetals, which are in green here, a lot less of them. And then the metalloids touch a whole line of the staircase of your reference table, and they include only a few select elements, which you see here in pink. One thing to watch out for is that hydrogen's all the way onto the left side, but technically it's a nonmetal. So make sure you watch out that it's kind of shown on the wrong side, and we'll have to figure out why it's like that later. And remember that the 7 diatomic, the 7-up rule, is still on that table, and they're all nonmetals. So let's talk about metals first. Metals are lustrous. We lust after them because they're nice and shiny. They're excellent conductors of both heat and electric. They're malleable, which means they can be hammered or rolled out into thin sheets. And ductile. They can be drawn into a wire-like shape so they can conduct electricity. Most of them are solids at a standard temperature and pressure, except for mercury, as we know, has been used in barometers and manometers and thermometers in the past as a liquid. The malleable and ductile properties come from the fact that metals are in little layers and they can slide over. So here's an example of the ductile copper, where normally we all shaped in a nice pretty arrangement, and you push on it, they just slide right past like rollers. Some people might get confused because they know of alloys such as brass or even the stainless steel and other types of mixtures of metals, and they think that that mixture is one of the elements. So if you don't see something that you know is metallic on your list of elements, it's actually a mixture of those elements, such as, like I said, brass. And that irregularity will actually make it strengthen and stop the force that you're pushing on it. The metalloids are semiconductors. They're kind of half and half metal nonmetal. They luster like metals, but they're brittle like nonmetals, and they're used for making computer chips in the most part. Their whole line touches a part of the staircase, like boron, silicon, germanium, and so on. There are 2 exceptions to that staircase rule. Aluminum and polonium are touching the staircase, but they're actually more metallic than anything else. And the nonmetals are poor conductors of heat electricity. They're brittle, so if you like hit on carbon, it just breaks onto pieces, right? It gets all crumbly. And they're dull, not very shiny like a metal is. At this point, you should be able to differentiate between the classifications of metals, such as metals, nonmetals, and metalloids.